This video is on the objective, use the cofunction identities. And this is number 1. This is the first video on a question related to this objective from your Newton Alta homework. So I'm going to be a little bit longer then. I'll be establishing some things, establishing these cofunction identities. So let's take a look. Alright, so again, if you're unfamiliar with the topic, please hopefully you've read sections 9.1 of your OpenStax Algebra and Trigonometry book. And if you want to also click on more instruction here and see what notes or videos or examples they have for you, and hopefully those help. Alright, so we're asked to write the following function in terms of its cofunction. Write your angle in radians and all that. Okay. So let's talk about these cofunction identities and how they're developed. So the cofunction identities. So first, before we get into what these are, let's remember some stuff about right triangles. So if I had a right triangle, there's a 90-degree angle there. That's not very 90 degrees, I apologize. And I got this angle A here, this angle B here, and say the 90-degree angle is angle C. And then the opposite sides, all right, the side length, the length of this side B to C is going to be little a, right? So the length of the side opposite the capital letter will be a little letter, all right? So the length of the side opposite side B I'll call little b, so that's the length of A to C there. And then the hypotenuse has length little c. So I'm going to try to make my big C's and little c's discernible. Now, one word you may have heard, maybe back in a geometry class, is that angles A and B in this right triangle here, they would have to add up to 90 degrees. Their measures, I should say the measures, add up to 90 degrees. Remember, because in a triangle, all three angles have to add to 180, and angle C is already 90, right? So these two have to add to 90 degrees, or if you're talking radians, pi over 2 radians, right? Pi over 2 rads. Now there's a name for this, right? When you have two angles that add up to 90 degrees, have a sum of 90 degrees, or a sum of pi over 2 radians, they would call those angles complementary angles. So A and B are what they call complements or complementary angles. And like I said, you've probably heard these words before. Two angles are complementary if their sum is 90 degrees, or if their sum is pi over 2 radians. Now let's take a look at the trig functions, right? The trig ratios for these. Now, if you look at the sine of angle A, the sine of angle A, well, that's, remember, sine is opposite over hypotenuse. So that's little a over little c. Well, do you notice how that's also the same thing as the cosine of b? Right? Because remember, cosine is adjacent over hypotenuse. And for angle B, little a is the adjacent side, not the opposite side. And then the hypotenuse is little c. So you see sine, cosine. The co stands for complement of. The co stands for complement, or complement of. So you have sine and complement of sine, cosine. And you see how the angles inside here are complementary angles. So the sine of one angle will be equivalent to the cosine of the complementary angle. Same thing goes for secant and cosecant, tangent and cotangent, right? The co is for complement of. So let's take a look at this. All right, how about secant? All right, look at the secant of A. Now remember, secant was the reciprocal of cosine. So the secant of an angle in a right triangle was the hypotenuse over the adjacent. So the secant of angle A is the hypotenuse over adjacent, little c over little b. Well, if I look at angle B instead, little c over little b is hypotenuse over opposite. Well, hypotenuse over opposite was cosecant. So the secant of angle A is equivalent to the cosecant of the complementary angle B. And then the same thing goes for tangent and cotangent. The tangent of angle A, remember, is opposite over adjacent, little a over little b. But then when I look at angle B, that's adjacent over opposite. When I look at B, little a over little b is adjacent over opposite. So that's the cotangent of angle B. So again, the tangent of angle A is equivalent to the cotangent of its complement. And this happens in general, not just for right triangles, but for general complementary angles. So here are, these cofunction identities. I'll write it again. So the sine of an angle, right? So the sine of some angle theta is going to be equivalent to the cosine of the complementary angle. So remember how you find complements. If I said, what's the complement of 30 degrees? You go, what adds up with 30 to be 90? That'd be 60. You just do 90 minus that. So the sine of one angle is the cosine of its complement of 90 degrees minus that angle. Or pi over 2. Or pi over 2. All right? If you're in radians. And vice versa, the cosine of an angle is equal to the sine of its complement, 90 degrees minus that angle. As long as the two angles add up to 90 degrees, the sine and cosine will be the same. And we've seen examples of this, right? The sine of 30 degrees is the same as the cosine of 60, right? Both of those were a half. The sine of 60 degrees was the same as the cosine of 30 degrees, right? Both of those were square root of 3 over 2. We've seen this before, just not actually written out like this, right? So sine and cosine are cofunctions. And we have a tangent, secant and cosecant. I'll do secant and cosecant. So the secant of an angle is equal to the cosecant of the complementary angle, pi over 2 minus theta, or 90 degrees. Again, I'll do degrees here, radians here. All right. Just depends on what measure you're in. And vice versa. The cosecant of an angle is equal to the secant of the complementary angle, pi over 2 minus theta, or 90 degrees minus theta, right, if you're in degrees. So the secant of one angle will be equal to the cosecant of its complement, right? As long as the two angles add up to 90 degrees or they add up to pi over 2 radians, their secant and cosecants will be equal. And then the last pair of cofunctions is tangent and cotangent, right? So the tangent of an angle will be equal to the cotangent of the complementary angle, right? 90 minus theta. Or pi over 2 minus theta if you're talking radians. And vice versa, right? The cotangent of an angle will be equal to the tangent of its complement. Again, as long as the two angle measures add up to 90 degrees or they add up to pi over 2 radians, the tangents and cotangents of these angles will be equal. Right. So again, co means complement. Sine and cosine. Secant and cosecant. Tangent and cotangent. All right. So these are the cofunction identities. Now, what we are asked to do here says again, write the following function in terms of its cofunction. Right, so what's the cofunction of cotangent? That would be tangent. And notice they gave us an angle measure here in radians. Right, so going back to my page, going back to a piece of paper here. Now let's bring this up. We were given the cotangent of a 3 pi over 10 radian angle. Now, based on all the stuff I just showed you, this should be equivalent to the tangent of the complement of 3 pi over 10. So now this is in radians. So pi over 2 minus 3 pi over 10, whatever that is, and we just need to figure that out. All right. So let's do this. What is pi over 2 minus 3 pi over 10? There's fractions here. Get a common denominator, which would be 10. This is 5 pi over 10. That's the same as multiply by 5 over 5 minus 3 pi over 10. So put them together, you get 2 pi over 10, which would simplify to just pi over 5. So putting all this together, we have the cotangent of 3 pi over 10 must be equivalent to its, you do the cofunction, which is tangent, and then inside here you put the complementary angle, the angle that when they are added together make pi over 2, and that'd be pi over 5. And you can double check, make sure 3 pi over 10 plus 5, pi over 5, that'd be 5 pi over 10. That'd be these two angles add up to pi over 2, and we have cofunctions, so they should be equal. So this is what they're asking us to type in, right? And let's verify this, right? Let me verify this. I'm gonna pull up a calculator, and make sure that I'm in radian mode this time. Yeah, radian mode. All right, so now if I want to do cotangent, remember you got to do 1 divided by tangent. There is no cotangent button. So I'm doing 1 divided by tangent of, and then inside that 3 pi over 10. 3 pi over 10, close the parentheses, and we're getting some value of 0.72654, so on. So that's the cotangent of 3 pi over 10. Now let's see if it's actually equivalent to this other side, right? The tangent of pi over 5, the tangent of the complementary angle, and look, they are indeed the same value. And that will always happen, again, as long as you have your cofunctions and the angles inside are complements. They add up to pi over 2, they add up to 90 degrees, the statement will be true, they will be equal. Alright, so again, back on the website, what they're asking us to type in here is the tangent of our angle, right? So the cotangent of 3 pi over 10 is equivalent to the tangent of pi over 5. So the pi symbol there, pi over 5. And let's close the let's close. Oh, there, I guess the parentheses are already closed. Okay, so tangent of pi over 5. Submit. And fantastic, right? And then you go through the same explanation I just did there. The cotangent of an angle is equal to the tangent of pi over 2 minus that angle, or if you're in degrees, 90 degrees minus that angle, the complement. Okay. All right, so hopefully this video helps you out when you're going through this kind of a thing on your own. and thank you very much for watching.